Assalamualaikum and good afternoon. This is Marina again. So we are going to continue our lab 27.2.15. Yeah, I hope students have done part 1, investigate with Kibana. So part 2 is investigate the exploit with Sigil. So in part 2, yeah, we will use Sigil to check the IDS alerts and gather more information about the series of events related to the attack. So let's do first step. We are going to open Sigil and locate the alerts. So please log in as usual, username, analyst, and password, CyberOps. And make sure you enable all sensors. Yeah, select the network and start. So what we're going to do, we're going to locate the group of alerts. Yeah, so let's wait for it to come up. Okay, so we are going to locate the alert from January 27. Okay, so the first question is, according to Sigil, what are the timestamp for the first and the last of the alerts that occurred within about a second of each other? Yeah, so look for 27 and you will find the answer. Okay, so next we are going to from 2254, yeah, check your answer, 2254, until the last attack on 27th January, 2255. Very good. So in step 2, we are going to investigate the alerts in Sigil. So what we're going to do, we're going to click the show packet data and show rules. There you go. Check boxes to see the packet header field information and the IDS signature rule related. So first select 5.2, make sure, yeah, alert ID 5.2. So the question is, okay, according to IDS signature rule, which malware family triggered this alert? So we need to scroll through the alert signature there and find the entry. And the answer is there, yes, sudo dark leech. Next, maximize the Sigil window. All right, so we want to see the text of the entire message. So let's try to do that. And answer the question. According to the event messages, what exploit kit EK is involved in this attack? So we are going to resize the column. Okay, let's resize it bigger a bit more. Yeah. So you will see, yeah, there is the rig EK exploit. So beyond labeling the attack as Trojan activity, so what other information is provided regarding the type and name of the malware involved? So you can see ransomware, yeah, is one of them. And by your best estimate, looking at the alert so far, what is the basic vector of this attack? And how do you think this attack take place. So by looking at the entry, the attack seems to have taken place by visiting a malicious web page because, yeah, there's port 80. So 80 is HTTP. So that rig exploit hit, yeah, from port 80. So that's it for part 2. Let's move on to part 3, view transcript of events. So what we're going to do is, first, we are going to right-click the associated alert ID 5.2 and choose transcript. So the transcript came up. So we are going to answer the question, what are the referrer and host websites that are involved in the first SRC event? So what do you think the user did to generate this alert? So the user, yeah, looks like it should search on Bing with the search term, that one, home improvement, remodeling your kitchen. So the user actually clicked that website and visited that site. So move on to the next alert ID 5.24, same thing. We are going to see the transcript. So it will open the conversation, transcript conversation. So the question is, what kind of request was involved? So let's have a look. We see, yeah, that HTTP 1.1 GET request. And what are the files requested? Any files requested? Do you think? Yeah, the JavaScript file. Yeah. So let's move on to the third alert ID 5.25. Transcript again. And here, the first question is, how many requests and response were involved in this alert? So if you scroll down, yeah, you will actually see between the blue and the red font, yeah, there are 3 requests and 3 responses. So why don't students, yeah, there are many questions here. Okay. Okay, try to answer the second one. What was the first request? Yeah, the GET request. Yeah, the GET Vivaldi request. So I want you to try and answer all of those questions, yeah, by investigating this transcript. And we also have the CWS file signature. Okay, so you need to actually copy and open it in the website. Okay, because you will be able to search the file signature to find out what type of file downloaded in the data. So we're going to do the last one, yeah, F, choose the network miner. So we want to see, instead of looking at the transcript, we are going to look at the network miner. So go to files and so answer this question, how many files? I think, did you see this one? It was 5.24. Yeah, I accidentally clicked on the wrong file. You are supposed to click on 5.25. So yeah, let's correct that. So please click 5.25, choose network miner. Let's redo this. And go to files. So how many files are there and what is the file type? So there are 3 files. Yeah, two are HTML files and one is the SWF files. So that's it for part 2. Yeah, network miner and transcript. We are done. Yeah, we're using SQL. We still use SQL. So now we are moving on to part 3 to use Wireshark to investigate. So still in SQL. We are going to go to alert 5.2, right click, and not transcript, not network miner, but we're going to use Wireshark. So the default Wireshark setting uses a relative time per packet, which is not actually very helpful for isolating the exact time. So what we're going to do this, we're going to fix this. So we are going to select to view. So go to view and then find time display format and then choose date and time of day. Next, we're going to repeat the same thing, but we're going to choose seconds. There you go. Your Wireshark time column has the date and time stamps. All right, that's what we want. So step 2, let's investigate the HTTP traffic. Now we're talking about part 80, yeah? So we are going to go to the display filter to filter for web request only. HTTP dot request, yeah. So we end up with 3 files. So we're going to select the first packet and then expand the HTTP protocol down there, the application layer data. So let's answer this question. What website directed the user to the home improvement website? So the answer is yes, very good, bing.com. So we are going to go to step 3, which is view HTTP object. So in Wireshark, yeah, we can view the objects. So please go to File, Export Objects down there, and then HTTP. Okay. So there are 3 files. So we're going to select the remodeling your kitchen cabinet HTML and then save it to our home folder. Yeah, actually not home. We don't have the permission. So we need to actually just leave it at home analyst. So let's do this again. Yeah, there. Okay. So it's already there. So it asks, okay, don't want to replace it. We already have it there. File already exists. Okay. So let's close Wireshark. So in SQL, right click, we're going to do 5.24 and choose Wireshark again. We're going to do a few and apply the same thing just now. HTTP request. Only one line, and we want to answer the question, what is the HTTP request for? So if you can see, it's actually a JavaScript file that is named DLE javascript.js. And what is the host server? That's the answer. Yeah, retrorip.visionurbana.com. Instead, go to file export object HTTP again, yeah, and save the JavaScript file to our home folder. We're gonna save this one. What are we going to do next? So now we're going to go to 5.25. So go to Sigwheel again. Close Wireshark. 5.25. Wireshark. And then apply HTTP request. And then we will end up with 3 files. Yeah. They are get, post, and also get request. We have looked at this earlier. So we select the first packet. So in the details area, we're going to expand the hypertext transfer protocol application layer data. So find host information, scroll down. Right click and choose apply as column. There it will appear, yeah, on the packet list column. So to make room for the host column, we're gonna right click length and remove it. So untick length. So yeah, we can see the info much longer. We can see the server. So step 4, yeah, interesting. Yeah, you learn this in cryptography, how to create a hash for an exported malware file. So we know that the user intended to access homeimprovement.com, but the site referred the user to other sites. So eventually, yeah, files were downloaded to the host from a malware site. So in this part, we will access the files that were downloaded and submit to file hash to VirusTotal to verify a malicious file was downloaded. So in Wireshark, yeah, go to export objects HTTP. We are going to save. So let's see what come up on HTTP. So there are 3 files. So save all the 3 files to our home directory. Just save all. Yeah, all 3. Yeah, save all. Yeah, to choose home. So now that you have saved the 3 files to home folder, so we want to see and test if one of the files matches a known hash value for malware at virustotal.com. So we're going to issue the list file, list -l, to look at the file saved in our home directory. So there's quite a few. Yeah, I think I accidentally saved more than once. So there are like copies over there. So don't worry. We're going to delete it after. So we're going to grab to filter out the file name. With the pattern, we want to see whether those file has cmonkey in it. Okay, so we use -i to ignore the case distinction. Yeah, so there are 2. Actually, we should get 1. So we're gonna delete it. So why don't students say if you have 1, that's great, but if you have 2 like me, you're gonna have to delete one of the files. So what you see, after this, we want to generate a SHA-1 hash. Yes, so we have a few SHA, but we're going to use SHA-1 to create hash for the cmonkey flash file with the command SHA-1 sum, followed by the file name. So our file name is actually that, what is that? %3FB, and then just use tab. Yeah, that's how we use it in Linux. So tab key to autofill the rest of the file name. It says here no such file of directory. So I think this has to do with what because we have duplicate files. So we need to sort it out. We need to delete the duplicate file, and then we finally managed to only have 1 file. Now that hash appear. Okay, so the hash actually is a 40-digit long fixed length hash value, that one, 97A80. So actually, we can also create the hash value by using Network Miner, much faster one. So why don't we go back to Sigwheel and go to 5.25 and choose, right-click, choose Network Miner. Select the file type, just like before. So we are going to go for the flash file, the SWF extension. Yeah, and select calculate. Yeah, so there are a few hash algorithm MD5, so we're going to use that. So it will calculate SHA-1. Find SHA-1. There's also SHA-256. Yeah, so yeah, isn't it the same as the one that we use the SHA-1 sum command in terminal? So compare the SHA-1 hash value, yeah, and positively positive that the value is the same as what you've seen in the previous step. So let's just compare it. Yeah, 97A80, blah, 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 blah. Okay, so what we're going to do next is actually we're going to search whether, we're going to search that thing from inside web browser, the virustotal.com. So please click the search tab and enter the hash value to search for a match in the database of known malware hashes. So that hash is an identity, of the malware. And enter. So the VirusTotal website will return a list of the virus detection engines. It should that have rule that matches this hash. So let's wait for it. Yeah, all are in red. So what we're going to do is we are going to, where is it? Investigate the detection and details tab. So review the information that is provided on this hash and answer the question, what did VirusTotal tell you about this file? What do you think? So have a look. Yeah. You see the SWF part, which is probably the rig EK exploit kit. And then, 32 of the 55 antivirus programs have rules that identify this hash as coming from a malware file. So there are a few more things that you can actually gather from here. So let's close the browser and the Wireshark. So go back to Sigwheel. So close this. And go to 5.37 and Wireshark. And examine the HTTP request. So look at the HTTP protocol. Are there any similarities to the earlier alerts? What do you think, students? As you can see, yes. The alert shows GET post and GET request. We saw that just now. And please, answer all those questions in the lab sheet. Students, that's it for part 3 using Wireshark. So we are going to our last part of this, which is we are going to examine the exploit artifacts. So remember, we exported some documents from Wireshark. So let's go to Security Onion and open the remodeling your kitchen cabinet HTML. Interestingly, my sister is remodeling her kitchen right now. So I better tell her to be careful with this malware. So open it with your choice of text editor. Yeah, we have opened it. So we need to find the two places that are part of the drive-by attack. And then go to the second one. We're going to choose a different one, Vim. So what does this file do? The JavaScript file do? So it actually, yeah, it's a document that will write the content of the web page, creating an iframe that takes the user to bandme.com. So how does the code in the JavaScript file attempt to avoid detection? So this malware, how does it avoid detection? But interestingly, yeah, what it did is it split the iframe. Look at it, yeah, iframe tag. There are actually two iframe tag. One, the full one, and the other is the iframe plus IFR plus AME. Next, yeah, the last one, we can open Vivaldi. And so what kind of file is this? It is HTML web page. So what are some of the interesting things about the iframe? Do you think it called anything? Yeah, actually it is hidden. Yeah, interestingly, because it's called a start function. So what do you think the purpose of that? Yeah, it's actually to determine the type of browser that the web page is displayed. So students, that's it. Yeah, for the part. So the last part is actually the reflection. So exploit kits, EK, are fairly complex exploits that use a variety of methods and resources to carry out an attack. So interestingly, EKs may be used to deliver diverse malware payloads. This is because the EK developer may offer the exploit kit as a service to other threat actors. So therefore, EK has been associated with a number of different malware payloads. So what I want you to do is, yeah, please investigate the data further using the tools that were introduced in this lab, yeah, Kibana, Sigil, Wireshark, and please complete the table below. It is very useful, yeah, because this table will help to tell the story of an exploit, yeah, to understand what happened and how it works. So please start with you searching the internet. Yeah, search for more information on the RIG-EK to help you. So students, that's it for lab 27.2.50, investigating a malware exploit. So we have achieved the objective of learning the 4 parts, yeah, using Kibana to learn about malware exploit, investigate the exploit with Sigil, use Wireshark to investigate the attack, and finally examine the exploit artifact. So I hope, yeah, you know what a tier 1 cybersecurity analyst does, okay? And you have more understanding on how to investigate a malware exploit. Bye.